So we are now on our last topic for Module 4. And we call this one a shift register instructions. When we try to talk about shift register instructions, we are now talking about uh, multiple bits that we try to shift a value of 1 or 0. Kasi when we try to talk about shift registers, we are trying to shift a value of 0 or 1 to a series of bits within a particular variable or integer or word. Ano? Pag word is, we call that one as twice the number of bytes. Ano? 1 byte is equal to 8 bits. 2 bytes is equal to 1 word. So we have 16 bits into 1 word. It depends on our application if we need that kind of number of bits, yung tinatawag nating 16 bits or one word, when we try to work on with shift registers. Shift registers are very, sabihin natin, popular with becomes to counting. Bukod sa counters kasi, we could also use shift registers to count um, a much amount of values or numbers up to 32,000. No? Ganun ang dami ng bilang na pwedeng gawin ng isang shift registers with the manipulation of ones and zeros lang. Naintindihan natin to once that we try to actually use the once that we actually try to use this one on an application. Ano? And also, shift registers are very popular in being used on traffic lights. Ano? Also, in traffic lights. To further understand the use of shift registers, we have shift left, shift bit left, at saka shift bit right. Ano? So let us first have some idea kung anong instruction yung ginagamit natin for that. So shift register instruction has this particular uh, function instruction. For Siemens, we have this one, shift right. We have also SHL, which means shift left. Sa Allen Bradley, later on, we will be using this one, bit shift left, at saka bit shift right. BSL and BSR. Sa Omron naman, we are trying to use the shift function SFT. Ano? But for now, we will be using Allen Bradley for the time being. Ano? So to use this particular instruction on an Allen Bradley PLC, so let us try to escape this one. Let us try to open our application, our Micrologics 1000 analog. So to use that, so click on New. Micrologics 1000 analog again. Ano? So we are brought out again with a new screen. Now, when we try to shift, there are two things that we need to consider. Una is the shifting, is the shifting instruction, which is a normally open contact. Kasi para siyang counter that you need to give a pulse, a rising value of 0 to 1 in order for it to shift left or shift right. Then the next one na kailangan natin magamit is yung the value of the passing of data, either 1 or 0. Those are the things that we need to have. So I need to have two rungs for this activity, just for the purpose of seeing how does it work. So insert rung, insert rung. So I need a normally open contact. Ito yung pang shift natin, ano? This contact will be used for the shifting. This one is being used naman for uh, indicating if the value that is being shifted is either 1 or 0. Gagamit din tayo ng coil. Ano? Then, punta tayo ngayon sa tab na file shift. So, ang gagamitin muna natin for this is yung bit shift left. On the bit shift left, you have file control, bit address, then length. Ano? So, I'll put the length to, let's say for example, yung buong word file sa integer natin, yung n7 colon 0. Or we could put this one as a smaller length value. It depends on the particular application. I'll be putting this one first muna sa 3. No? Then the file bit that we will be using is an integer. Ano, yung file natin is an integer. So yung offset natin na n7 colon 0, yung file bit natin. The control would be a register. Ano? Kita naman, R6 control. So yun yung gagamitin natin. So this would be R6 colon 0. This is a particular standard for the bit shift or shift register. Then the bit address, the one that is being activated, whether that would be 1 or 0, yan yung ating pag-uusapan sa ngayon. So I'll be using first um, an input that would be shifting the bit shift left. So ang gagamitin natin to shift the shift register is I colon 0 dot 0, I colon 0 slash 0 to shift the instruction to the left. Then I colon 0 slash 1 naman to indicate yung ating magiging bit address, whether that would be 1, 0. Sa binary natin, yan ang gagamitin natin as to what would be the value of the shift. Ano? So gagamitin ko is B3 colon 0 slash 0 dito sa output ko. And also, at the bit address, ang yun ang gagamitin ko din. So ganito ang idea. Kung anong value neto nung B3 colon 0 slash 0, let's say ito yung 1, at nag-shift ako to the left, yung value dito ng bit address, which is 1 sa ngayon, kasi naka-activate kunwari ito as 1, will be shifted to doon sa integer natin to the left. So yun yung mangyayari dito sa activity natin sa ngayon. Para mas lalo natin maintindihan, let us simulate this one. So verify project, then save. So I'll have this one as automation, then RS. Then the decimal is 1. Ibig sabihin station number then, irarun natin si RS Emily. Now, I'll need to go online. So hintayin lang natin na make sure that RS links is open when we try to work on with the simulation. Now we have our program online. So to, minimize ko lang. Then I'll have my integer data file open. Then yung radix natin will be changed muna to binary para makita natin yung activity nung n7 colon 0. Okay, so we have n7 colon 0. Babantayan natin yung values na to. Now, yan, much better para kita natin yung ano natin. So once na nag-shift ako ngayon, toggle bit. Sir, wala nangyari. Ano? Bakit walang nangyari? It's because at that moment, at that point na nag-shift tayo to the left, the value of B3 colon 0 slash 0 is what? 0. Yun ang value niya. So, there's nothing to be shifted but 0 is because that our value for BT colon 0 is just 0. But when we try to toggle this one and activate it to 1, sa ngayon, ang value ng ating binary bit B3 colon 0 slash 0. So para mas maganda natin makita, let us open the binary folder, data file. Ano? Ngayon, B3 colon 0 slash 0 is 1. Now, pag nag-shift tayo, toggle bit, notice, at N7 colon 0 slash 0, the value ngayon ng ating bit is shifted to the left and the value of that is 1. Toggle bit natin uli yung pang shift natin. Then, toggle bit ulit. Nag-move ngayon to the left. Yung from 0 to 1, lumipat yung bit natin papunta sa left. And at the same time, nagdagdag tayo ng 1 dito since the value pa rin ng ating B3 colon 0 is still 1. So, untoggle natin yung ating pang shift. Gawin natin itong 0. Toggle bit. So, 0 na ngayon si B3 colon 0 slash 0. 0 na siya ngayon. Ngayon, pag nag-shift tayo pa left, ano magiging value ng N7 colon 0 slash 0? Ano magiging value dito? Kasi alam naman natin na itong dalawang 1 na to mapapalipat sa kaliwa ng 1 bit. So, ano magiging value dito? Ano? So, shift natin. Ang mapapalipat sa kaliwa ngayon, ang move ngayon sa kaliwa, since B3 colon 0, yung bit address natin, the B3 colon 0 slash 0 is 0, ang value niya. So therefore, yung mapapashift na value papunta sa left, papunta dito sa 0, is actually 0. Sa N7 colon 0 slash 0. So ganoon ang bit shift left. Pag bit shift right naman, pakara naman yung movement niya. So, toggle bit uli natin. Inantoggle lang natin. Tapos, itoggle uli natin pang shift. Since ang value uli ng ipapasa natin is 0 kasi hindi naman natin to binuhay, si BT colon 0 slash 0, pag tinagel ko siya, pag shift ko siya, the value would still be equal to 0. Gawin ko ulit itong 1. Toggle bit. Naging 1 na siya ngayon. Now, pag shift ko siya uli, toggle bit, the value of our integer na ngayon na shift is 1. Toggle bit ulit. 1 uli yung napalipat. Kasi nga, ang value ng ating B3 colon 0 slash 0 at that time is equal to 1. So, ganun yung shift registers, yung shifting to the left, na instruction. Most of the time, we try to always use the bit shift left. It's because alam naman natin na ang hierarchy ng isang logic circuit, and yung micro-C ninyo, sa understanding natin, yung galaw ng ating, yung hierarchy kasi ng ating bit system is from left to right. Where your, is from right to left pala. Where your left side will be your most significant bit and your right portion will be the least significant bit. So, ganun yung ating understanding pagdating sa shift registers. Now, sir, ano kahalagahan nito sa program natin? Anong silbi nito sa program natin? Anong mga application na pwede natin gamitin? So we could actually create a traffic light instruction using bit shift left and timer.